All right, this is going to be a short video on the Ready Go for 1.3. I'm going to start with the retrieval. Your work should be the ready and the go. I know I don't focus on the go much with terms in the sequence, but this is not as complicated as it's going to be. If you listen to these problems here, these two problems right here, I'm going to show you how easy it is. It's just a matter of the notation. So in the first section it says multiply using the distributive property, and then we're going to add like terms. So they're just having us practice the distributive property. Again, this is my thought process here, showing the arcs. So x times x, you have to stop and think about what x times x is. That is not 2x, it is x squared. X times 9 would be 9x. You've got to bring down the addition sign in between the two terms. It doesn't disappear. 2 times x is 2x, 2 times negative 2. Well, 2 times 2 is 4, but a positive times a negative is negative. You've got to pay attention to the signs. Now I'm going to combine like terms, left to right. No other x squareds, x squared. 9x plus 2x, 9 plus 2 is plus 11x minus 4. You're done. That's it. Carry the same thing over to the next one. This is very similar to what we've done before. Notice there are not two groups though. Since there's not two groups, I can't regroup thing, or two pairs. I can't group them into two pairs. So I just continue to multiply like they want me to do. 3x times 2x is 6x squared. 3x times 3. 3 times 3 is 9. It's going to be positive. X times, just bring the x. Negative 3 times 5, that's going to give me a negative. 3 times 5 is 15. Again, focus on numbers, then letters. Numbers, then letters. Sign though, negative times a negative, that's positive. Notice how I establish it's positive before I even multiply. 3 times 4 is 12. Now I can combine my like terms. No other x squareds, that's gonna be there. 9 minus 15. There's more negatives than there are positives, so my answer is going to be something x. What's 15 minus 9? 15 minus 9 should be 6 plus 12. Answer's there. Done. Okay, so those are just two examples of how to do 1 through 9 on the ready. And actually, 1 through 9 on the ready is even simpler than that because there's no addition. As far as the go here, you have to remember, we don't actually discuss how to create these recursive equations, but you have to remember what f of n minus 1 is, and all that is the previous term. That's notation for the previous term. So if f of 0, if 0 is negative 23, what's the next term in the sequence? Well, I take the previous term, which is 23, and I add 4, right? So what is 23 minus 23 plus 4? Well, I'm still going to be on the negative side of things. If you think about a number line here, I'm way over here. Here's negative 23. If I add 4, I'm still on the negative side. So that would be 19. And I want the next 5 terms in the sequence. There's 1, 2, 3, 4, and 5. I need the next 5 terms in the sequence. So I got the first one, 19 plus 4. That should be negative 15. Negative 15 plus 4 should be negative 11. Negative 4 plus 11 should be negative 7. And then we should go negative 3. That's how we should keep going. All this is the previous term plus 4. Previous term plus 4. Previous term plus 4. Now, down here, same thing. What is g of n? Different function. Previous term. What do I do with the previous term? Well, the first term is 1. What do I do with that? I multiply it by 3. 1 times 3 is 3. So there's my first term in the sequence. 2, 3, 4, 5. What is my second term in the sequence going to be? Well, 3 times 3, which is 9. 9 times 3, which is 27. 27 times 3, which is 81. 81 times 3 should be 243. Right? So there's an example of how those sequences work, and we would just keep going. The little dots here would indicate that we just keep going in that sequence there. So look at Google Classroom, look and see what you have to do as far as instructions, right? I'm not going to tell you here because I want you to look on Google Classroom and see the instructions.